I'm Alexander Morton, working with Datavid. Yeah, I don't know if you've seen the previous session, but we have lots of things to show, many slides to go through, but we're going to try to focus on three main topics. First one, we went through during the other session as well, but I want to reiterate why would you use these technologies? Why would you do entity extraction, and present some use case where it was useful, and maybe bring some ideas of where you can use it to know why would you put in the work. Then we're going to show the Datavid Rover, but in the context of entity extraction, in the context that James mentioned with the job description, because Rover is much more than that and can have other use cases such as search and storage. But yeah, that's maybe for another presentation. And then I want to see, this is a deep dive session. We want to deep dive into the entity extraction, have a look under the hood of Rover, and how we managed to build the extractors we have there. So the first part, as I mentioned, is let's talk a bit about the use case. Why would you do this? Why would you invest time in getting entity extraction, and what can you do with it? One use case we saw quite a lot in our clients is discovery. So basically being able to discover your data easier, do cognitive search on top of it. This was one of the use cases we had, is a client from the life cycle industries, which had lots of R&D research data, which was stored everywhere in like file shares, SharePoints. So we build an app where you get those from different sources, you extract the text, you extract the concepts, and then you can make it easier for them to do more intelligent cognitive search on top of that, and easily discover and browse their data. Another important use case would be automation. Now, on top of the entities you have, you can put certain rules allowing you to automate some of the business processes you have. Basically, a use case we saw on that was a company that wanted to automate the business process of validating some permits. So they were receiving the permits in the email. They had to check, okay, are the permits fine for that location? Are they still valid? Look at the date, look at the location, look at the company. If everything seems fine for some business rules, push it through. Now, being able to extract those, you can then put your business knowledge on top, put the rules in, and then you'll automate that process. Another big use case would be compliance. So here we had we tried to improve for a financial company, improve the fraud detection process, and it worked pretty much as automation. But after you extract and make your data more structured, you can then put certain alerts or have some indicative of how compliant you are at a certain point, and yeah, keep all that data and make sure you're always complying with the regulatory stuff. And of course, visibility. This is basically to have more visibility in your data. So extract and make certain links based on the extractions and the entities you make. You can link documents, and then you'll have more of a 360 view on your data. So you'll know that this document has same entities as the other one, and you know that this entity is a person, and you have his contact details from AD. So you can tie all this up together and have a better insight and better view of your data. So if we got into the use cases, we've worked in Datavid on all these sorts of use cases, and then we saw that some things are related, and we can start to build some accelerators to speed our work in doing this. And this is how the Datavid Rover was born. Now, first I want to show you just that light UI, and the idea will be to show what Datavid Rover can extract. And I'm going to open the demo for that. Let's hope the demo gods are in our favor. So we have, as James mentioned, we have some job description. In this case, I only put 3 job descriptions. They're all in unstructured format, PDF. I just dump data in a PDF. That's it. And we have the Rover Lite UI. It doesn't have the search functionalities enabled. It's just here. I've just put it to show the extractions. And I'm going to put this document in the documents in an S3 bucket to get processed. Now, Datavid Rover will actually be able to support more ways of loading data from your local drive, from cloud, AWS, Azure, might be able to support Google in the future as well. So they already processed. They are like 2-page documents, 1-pager, so it went quite fast. And let's open and see what we got from the extractions. Now, it's a simple document, and this is what we apply the general model on this document. So basically, a model that knows how to extract things like money in this case, person, which I see got it wrong, dates, and location. Now, you can already see and you got dates such as also in format of a date, but also such as periods. You can already see some use cases where you would start already to make use of this information in filtering your job descriptions, like categorizing it per salary, or categorizing it, having already the dates extracted. You already have more structure in your data. Now, this is using a general model built on top of lots of Wikipedia articles. So it knows how to extract general stuff that are not specific for this domain or this problem. But we also, for this job description use case, we also built a custom one, which besides the fact that it knows to extract, again, dates, organizations, products, it can also extract programming languages. And this is the custom name entity recognition and the custom NLP that I'm going to talk about and show you how it was made. Now, yeah, these are just the general extractions, and you can see the programming languages extracted here are Perl, Java, and it's all Perl again somewhere down. I've put one with more programming languages just to show that it can do much more than just 2 programming languages. Didn't get them all, to be honest, but yeah, I'm going to get to that as how you measure and how can you improve your extractors in time. Yeah, so yeah, let me then go back to the presentation and show you a bit, do a better deep dive on what you saw here and explain a bit what's under the hood of this. Now, the Datavid Rover is basically a set of APIs. So we try to have it as modular as possible, so we can change a few components if we need to. Basically, you have functionalities, APIs for each functionality, like storage, upload, different extractors that I'm going to tackle in the next part, logic, of course, and then also an data orchestration to orchestrate the entire pipeline of processing a document. Also, it's going to have a UI. It's going to be either this light part for the extraction, but you're going to have a more complex UI to be able to also do all sorts of search and have a graph visualization of your entire data. Then diving deeper into entity extraction, we described in the previous session that we are doing, in most of our cases, 2 types of entity extraction. Either entity recognition, which is based on some of tag data. As I mentioned, the general model is based on tag data script of internet, and the programming language one is based on, again, some Stack Overflow data, and some of them had to be tagged manually as well. So there are 2 types. There's also what I mentioned, entity recognition, entity linking. So basically, entity linking is going to be based on rule-based information extraction. So basically, you're going to write some rules. If the pattern is matched, then you're going to say, okay, this token is category 1. And entity recognition, which was the model-based one, it's basically you training a model to figure out that whenever you're going to see token 2 next to token 1 and token 3 is going to be either category 1 or category 2, and you're going to take the one with the highest probability. So jumping from the theory, this is basically known in the NLP field as named entity recognition. So basically being able, giving a set of tokens, like a sentence, being able to correctly categorize some tokens based on some entities you need to extract. Like in here, person, location, ordinal, date and time. And there are lots of open source state-of-the-art models that can do this for you, but yeah, have a limited set of entities. Because you have a limited set of entities, you might be in the need to build your own custom named entity, as we did for these programming languages. And the first and arguably the most important part of this will be your data set. So you're going to need to either find data in your data storage inside your company, find tag data, or even start to use a tool for tagging, which can do parts of it, can be automatically tagged, but then you're going to need to have someone to verify it. Because there's a concept saying that garbage in, garbage out. So you can have the perfect model, but if your data is bad, then your model is just going to learn the things that were wrong in your data and use them further in predicting. So you're going to put, if you're not careful on how you manage your data set, the named entity for this is not going to work. After you have your data set, you're going to need to train your model. So basically, there are lots of more in-depth definitions of training, but if you look at just a higher level, basically you're going to have a training data, which you're going to have the text and the assigned label for each token, and you're going to gradually continue to train a model, and then you're going to evaluate using the gradient descent function, and you're going to try to minimize that loss your model is still doing, and try to have a model, generic one, that is going to try to predict as better as possible with the data you have. Training a model requires also some parameter fine tuning, because the model is going to train in epochs, and you're going to use batches in this epoch. So you're going to train batch by batch. So you can play a bit around with the batch size and the number of epochs for training a model. There are tools for doing that as well, or trial and error, and yeah, keep on improving it. You're going to have your model, but you need to know how good it is. You need to test it out. It's not as a normal development work where you build something, you see it works. You need to measure it. And for that, there's industry standards for measuring information extraction, which is the F1 score. Now, the F1 score is made of precision and recall. And basically, precision means that out of the ones we had to extract, how many tokens are correct. So we had to extract 9, and 6 of them are correct. And recall is out of the ones we had to extract, how many did we manage to extract. So recall gives more of an idea of completeness, and precision more of an idea of correctness. And the F score is basically just the harmonic mean between these two. So it's going to try to give you a direction of how complete your extraction is, but also how correct it is. Then images and visualization tool you can use for this is the confusion matrix. So basically, you can put on one dimension what your model classified, and on another dimension what is the actual correct value for that. Okay, so ideally you want to be on the diagonal. So of course you want your model to when it sees an actual dog, to classify it as a dog. It's the same. But then you need to look at the places where your model is confused. That's why it's called a confusion matrix. So apparently your model, whenever it sees a rabbit, it seems that it classifies it as a cat. So you need to work on those areas and see, okay, what can I do to shift that towards the diagonal. Now, going further, so you have, this is the entity recognition part. So basically, this is how you have some tag data, and you try to use that tag data to create a model and use it on future data points that are going to come and extract from those. Now, what we also do in Datavid and in Datavid Rover is entity linking. So basically doing extraction based on some existing knowledge base, or in this case, existing ontologies. That might be pretty easy if we think it without keeping in mind the context, because we can just take the words from your ontology, do a string match on the documents, and then we're going to say, okay, we extracted the concepts from your ontology. But there comes context in play, where you can see here the word bank can have multiple definitions depending on the context. So you would want to do more than just a normal string matching or a fuzzy match on a string, and you want to take into account the context when you apply these extractions. For this, you can actually make use of the generic NLP. So we went over the named entity recognition. So let's say we take a sentence. You can pass it to a generic model to get the named entities. You can get the part of speech tagging. There are state-of-the-art models for that as well. Just going to tell you that Datavid is a proper noun. Those are a verb. And then you can get also a dependency tree of this sentence. So from this, you can understand that the verb providing is actually talking about Datavid. Most data is talking about there is referencing businesses. So you have this dependency tree. So you know in a sentence which word is related to which one, to the other tokens. And then you can actually have a context-aware extraction by writing rules which are going to also use this dependency tree. So you can have, if you're going to have, for example, the concept person, which we might define as being a noun, a proper noun, in the same dependency, in the same sentence as the verb, which means that has age, and also that age is related to that number is related to the age verb. We can say, okay, this rule matches, it makes sense, it has the context we defined, and then we can infer that this is an adult, and we extract it as an adult. But to be able to do this ontology extraction, you need to build your knowledge graph, and the guys from Graphify are gonna tell you how you can use graphology to do that.